This is a supplement to Lesson 7. As I went through Lesson 7, I started to wonder about the relationship between the equations that we were solving and this form of an equation for a line. This was a linear equation in the slope-intercept form. So if you remember, this m was the slope of the line, and that was a measure of the length along the y-axis compared to the length along the x-axis. So that is called the slope. Plus, in the problems that we looked at, there was oftentimes a beginning amount. So it started somewhere, and that was the y-intercept. That's where this line, the graph of this equation, the line, crossed the y-axis. So that's called the y-intercept. So this is the y-intercept or the slope-intercept form of an equation. And I started to wonder, what's the relationship between this and the equations that we begin to solve throughout these next few lessons? Also, just as an aside, I think that this title should be all, one, or no solutions. You either have all the values of x are solutions to the equation, there's just one value of x that's a solution to the equation, or there are no values of x that are solutions to the equation. This is not a big deal in that they use this title throughout, and I'm not going to make a big deal of it. So as I start to look at, let's just use this equation as an example. I started to look at this, and I realized that, first of all, I'm going to change the r's to x's. I want to look at x's. And I started to realize if I go through a bunch of moves to make the form of this expression into mx plus b, so a coefficient of x plus a number out here, which is called a constant, by the way, never changes, plus b, and put this expression in that same form, y equals mx plus b, the slope-intercept form, then I could start to answer the questions, and I could actually draw a graph of that equation on each side, and I could visually see the answers. And that's what I want to show you, and that's the path I want to proceed to solve these equations throughout this lesson. So I'm going to put this in the form of y equals mx plus b. So it's a negative 4 times x plus 2, and on this side it's just 4 times 2, and I'm going to change this to adding the additive inverse, so plus a negative 2x. So plus a negative 2x, you make that change. This is in the y-intercept form now. This is a slope of negative 4, so for every unit along the x-axis, the line goes down 4 units along the y-axis. So that relationship is that y is a negative 4 times x, and it also starts at where the line crosses negative 8, y equals negative 8. On this side, it's a slope of negative 8, so for every unit x, the line goes down 8 units, so the y is a negative 8 times the value of x, and this one crosses the y-axis at 8. So all I did here was I made the left expression, this expression here, equal to y, and then I made some moves to put this left part of the equation or the expression on the left in the form of mx plus b, and I did the same with the right expression, and I said that that's equal to y, and that's okay. This side is equal to y, this side is equal to y, because both of these expressions are equal, so they're both equal to the same thing, to y. Now we can graph each of these equations separately and see what happens. So this first graph has a y-intercept of negative 8, so it's going to cross the y-axis at negative 8 right here, and it has a slope of negative 4. So for each unit of x, so 1 unit of x, it's going to go down 4 units. 1 unit down 4 units, and then you keep doing that, and then you connect these points and get this line. So this line has a slope of negative 4. So for every unit x, it goes down in the y direction 4 units, 1 unit down 4 units, 1 unit down 4 units, and it crosses the y-axis at negative 8. On the other hand, this equation crosses the y-axis, the graph for this equation, the line crosses the y-axis at positive 8. And for every unit of x, this one goes down 8 units. So not 4 units, but 8 units. So it goes down twice as far for each unit of x. So it's going down faster than this line. So eventually it's going to catch it. Eventually it's going to intersect this line. And it intersects this line right here at x equals 4. Well, it turns out that that's the solution to this equation up here. So when we solve this equation, I'm going to do that in a moment, you're going to see that x is going to equal 4. And then when we test that solution in the expression, you're going to see that, and if we put it into this equation here, you're going to see that y equals negative 24. So this is the only point that is shared by both of these lines. So you can actually see the solution graphically, and it begins to make sense. You're solving this equation for x equals 4, and y equals a negative 24. That's where both expressions, both sides of this equation are equal, the point at which they intersect at 4, negative 24 right here. All right, so I'm going to solve the equations. I'm going to get rid of this negative 8x by adding a positive 8x. So that's adding the additive inverse of a negative 8x. I'm going to get rid of this negative 8 by adding positive 8. So that's adding the additive inverse of a positive 8. So you end up with 4x equals 16, and 1/4 of 4x is x. And so you have to look at 1/4 of 16, which is 4. So x equals 4. And here's a way to simplify 1/4 times 16. Just write 16 as 4 times 4, and then these 4's cancel, you end up with 4. All right, so we solve the equation for x equals 4, and then we want to test, what's the, in essence, what's the y value for this side? So y equals, if x is equal to 4, what does y equal? And if x equals 4 on this side, what does y equal? And y has to, remember, be the same thing. So y equals negative 4x plus negative 8, y equals negative 8x plus 8. Replace this x with 4, and you get y equals negative 24. Replace this x with 4, and it has to be equal because these expressions are equal. So the equations, the lines intersect at this point 4, negative 24. So right at this point right here. So I like this because it's a visual way to see what's going on as we solve these equations. And it brings us back to the relationship of equations for lines, especially in the form of y equals mx plus b. And we can use this form to answer all the questions in the next few lessons. And this is important, and you don't have to put a huge effort into understanding this, because this is what we are going to do in the future. When we get to these lessons, lessons 10, 11, 12, 13, 14, and 15, they start to talk about systems of equations right here, especially in lesson 12 on. And this is what we're looking at, a system of equations. So this is one equation, this is the second equation. As a system, how do they work together? Well, in this case, these two equations intersect at this one point, so that's the solution for this system of equations. So now I'm jumping way ahead, but don't worry about it, we'll get there. So I'm going to use this idea, though, to look at the answers in the next few lessons. And you can either try to do it or just so that you get an idea of what's going on. And you're going to start to see, I think, that this is very useful to look at the slope of each of the equations and to look at where they cross the y-axis of each equation. And so the key of one last time is to separate this equation that you start with into two separate equations. Write each expression as a separate equation and get them into the form of y equals mx plus b, the slope-intercept form.